FULCRUM is complete. The case study is closed. But before we leave Series 2, I want to take you one step beyond what we built, into the cooling technology that is already being deployed in the most advanced AI facilities in the world. Into the cooling technology that is already being deployed in the most advanced AI facilities in the world. Not air, not rear door liquid. Immersion, where the server itself is submerged in a liquid. If you have watched all 20 episodes of this series, you have earned this one. It is the most technically adventurous episode we have made. The immersion cooling principle is a radical departure from conventional air cooling. It submerges server hardware, CPUs, GPUs, and power supplies directly into a bath of dielectric fluid. Dielectric fluid is electrically non-conductive, meaning it can contact live components without short-circuiting. The heat transfer is orders of magnitude more efficient than air because the fluid is in direct contact with the source. Hot fluid is pumped from the tank to an external heat exchanger, transferring heat to building cooling water. Cooled fluid then returns to the tank. No fans are required. Servers run completely fanless in immersion. This efficiency drives the power usage effectiveness down toward a theoretical minimum of 1.02. To understand this further, we must look at the two primary types of immersion: single-phase and two-phase. Single-phase immersion is the more mature technology. The fluid remains in a liquid state throughout the cycle. Single-phase immersion is the more mature technology. The fluid remains in a liquid state throughout the cycle. In two-phase immersion, the fluid boils at the component surface, creating vapor that condenses and returns. This latent heat of vaporization allows for extremely high heat transfer density, suitable for the densest AI chips. Single-phase typically uses mineral oils or synthetics, while two-phase requires higher-cost engineered fluorocarbons. Single-phase is operationally simpler, while two-phase requires vapor pressure management and hermetic sealing. Major cloud operators like Microsoft and Alibaba are already deploying single-phase immersion at hyperscale. Specialists like GRC and Submer are pushing the boundaries of what these systems can cool. But immersion cooling does not just change the cooling system, it changes the data center building itself. The structural floor loading is different. Tanks filled with fluid are extremely heavy, far beyond standard rack loads. The white space looks nothing like FULCRUM. It is essentially a series of tanks connected to a fluid distribution manifold. The infrastructure is more like a chemical plant than a conventional building services installation. Electrical distribution shifts to submersible-rated connections inside the tank, with no PDUs required at the rack level. Fire safety shifts too, from smoke detection in an enclosed space to fluid leakage monitoring in an open room. Operations change as well, requiring tank lifting mechanisms and fluid drainage protocols before maintenance. Let's compare the PUE across these technologies. Air cooling sits at 1.8. Two-phase immersion reaches 1.02. At 85 megawatts of IT load, the difference is 65 megawatts of wasted energy, enough to power a small city. The financial impact is staggering, representing an annual saving of approximately £390 million. Beyond cooling, the other major future trend is modular and prefabricated data center infrastructure. A modular unit is a factory-commissioned section of data hall infrastructure, delivered ready for connection. Deployment time: weeks instead of months. Scalability: add modules as demand grows. Decommissioning: remove them when the lease ends. Modular is not a replacement for campuses like FULCRUM, but it is transforming enterprise and edge data center delivery. The skills of project management and commissioning covered in this series are directly transferable to modular programs. It is time for the final series signal of building the machine Series 2. The data center that uses the least energy per unit of computation is the most efficient and the most sustainable. Immersion cooling and AI-driven operations are not future options. They are current deployment technologies. Upskill now. 2 series, 38 episodes, 1 10-megawatt co-location facility, 1 100-megawatt hyperscale campus. From piling to bulk supply points, from air cooling to rear door liquid and immersion, the data center industry builds the infrastructure the world runs on. We carry a responsibility far beyond any individual project. If Catalyst Grid has made you better at that work or given you more confidence, it has done exactly what it was built to do. Series 3 is coming. Subscribe, bring your colleagues, and keep building. My name is Kingsley Amufua. I will see you in Series 3. Subscribe, like, share, and comment. Goodbye for now.